Okay, so I've been getting some pretty good feedback on this, so I wanted to create this high-level overview video. This is using Raspberry Pi to run N8N. I'm using a Pi 4, 8GB, and it could probably be done on less RAM too. As we'll see, there's a lot of free RAM in this setup, but that's what I'm using. What I'm going to cover with this is just a high level of how this can be possible. One way of setting it up, and I'll kind of step through this to show like conceptually how this is done rather than like every single line of implementation. But if there's demand for like a more detailed version of this, I could do that. Just leave me a comment or something, but for now we'll just do the high level stuff. So what we're looking at here is my interface to this Raspberry Pi. It's currently plugged in, it's on my network, and we're connecting to it over SSH. And so this is pretty much what we're looking at here. This is TMUX, and so it's a terminal multiplexer. So in the top left hand corner we've got HTOP running, and this is showing all the good stuff running in the background, so I can keep an eye on CPU, memory usage. At a glance, so you can see it's really not using much for memory. I'm not even actually running the default GUI program that comes with this, their version of Windows. It's off right now, so the RAM consumption is like really low. So is CPU consumption. I'm going to restart this thing just so we can see it from scratch. Then we'll log into it and I'll step through a few different things here. So give me just 1 second while I unplug this thing, which hopefully is not going to be annoying. Just a sec. Okay, it unplugged. So I tried to do this last time, but it was not working out. So if I look at this, this is now going to say, all right, we're back to a default thing. So I'm going to plug it back in, and then we're going to shell into it. So just a sec. Almost forgot. This is what it looks like. This is a case I got online. Case was like $10 or something. The board was about 80. This entire setup, said and done, was probably about 120 because I had to buy some adapters. You could probably do it for about 100 or less. It's amazing you can get this much power out of this tiny little computer these days. So I'm going to plug this back in and then we'll get to it. 1 sec. Okay, it's plugged back in. It's booting up right now. So if we look at our N8N setup, for example, and run it, it's gonna basically not work because the server's offline. So that's fine. We'll give that just a moment to reconnect. I'm gonna make the terminal much bigger so we can see this, and then we'll continue on here. So let's crank up the text. I don't know, let's make it like really large just in case it's hard to see. Let's do like 20. It's gonna break my beautiful graphic when we log in, but that's fine for now. It's better to be able to read it. Alright, so let me adjust this so we can see the prompts. Hopefully it's coming in nice and clear now as far as reading a terminal goes. I know it can be a little weird sometimes when you're making a video about command line. Alright, that actually looks pretty huge. I think we can see this. Alright, so first let's talk about how to connect to this thing. When configuring this initially, I use a program called Etcher to etch an image of the Raspberry Pi OS onto the device for x64 architecture. You can find this on Raspberry Pi's website. Flash it to a standard SD card. I had to actually buy this piece of hardware. I didn't have one hanging around. I'll show it to you. This is a micro SD card USB-C connector. So this plugs into the laptop. You plug the USB micro card into it, and then you flash an image of Pi OS right onto it. The other thing to say after doing that is you have to create the ability to SSH into it by default. And so to do that, after you've flashed the device, you can go in, it'll be mounted, there'll be a directory that says boot. You have to create an empty file called SSH in order to enable that. But there's a little more configuration with it too with the newer versions of this stuff. Again, documentation is online. I could get into this in another video if somebody would find that helpful, but I'm just going to say the steps are go to it, download the micro SD, enable SSH, do the extra steps, and then you might even set up your local config like this. Say, so mine's kept here. I've created an entry up at the top. Can't really point. Okay, well, I'll point with the cursor. It's up here at the top left. This is the IP address of it on the local network. I got the IP address of it by connecting to a software on my machine to look at the IP addresses of devices on the network. So I was able to determine 106 was this one. You could also use your router. There's a lot of different ways to find the IP address. So find the IP address and then configure your identity for it. I'm going to use the password because by default you have to set up a username and password to get in. You can't just give it a key, I don't think. And so it's on port 22. With that configured, you're going to type in SSH. In my case, it's Raspberry. Let's try this again. It's Raspberry. That's weird. We'll just type it in. Oh, it's all in caps. That's why it's being interesting. Clear Raspberry. Boy, I'm just getting everything except for this today, huh? There we go. Alright, so when you do that, it's going to ask you for the default password. Now, this was specified when you were setting up the SSH config initially with the file. I could tell this would be a very long tutorial if I was to do it all from scratch, but it's going to be demand, I guess. Alright, so once you're in the machine, the next step here is for me to go into tops and all that to look at the system resources. So I created this script here. We'll take a look at it. It's called monitors.sh. And briefly what this does is it starts a tmux session if one doesn't exist, and it splits the windows up, and then it loads a few different things like each top. And over here you can see it's like grabbing Docker logs, and it's grabbing this other file called the temperature file, which we'll look at that in just a second. And then it creates all the panes and lays it out nicely. So if you were to execute that program or execute that shell script, it's going to launch tmux, and we'll see that in just a second. It's also going to launch this other file here. It's called pytemp. And what this one does is it basically goes in and grabs things like the temperature. Down at the bottom, you can see there's more than just the temperature though. I'd split this up later, but I'm just writing stuff right now. Moving quick. Down here you've got the usage for the temp.fs. That's your temporary file system. So we'll get into this a little bit, but let's just say up front that when you're using a Raspberry Pi, which runs on a micro SD card, it's a good idea to eliminate as many writes as you can from the card, because these tiny cards can wear out faster if you write more to them. So one strategy for that is you can take those logs that accumulate from Docker or the system, and you can send them to temp.fs. And temp.fs just means they're going to sit in RAM, they're going to sit in memory for a while. And so instead of writing to your file system, it sits in RAM. And when it sits in RAM, other than not dinging your file system, that creates like a way where you can use all this extra RAM you've got on this device at the moment for something like storage. So there's a whole gigabyte of that allocated. Okay, we'll get more into that later. The next thing on the line is the disk usage, and that's going to just be your total disk usage for the device. So with those things in place, we can run this monitor script, and since there's not a tmux session, it'll create one. Top left hand corner looks like a mess right now. That's where my cool logo was, but the font's like way too big. But you can see over here we're running at 310 megabytes. That's basically the OS plus Nginx plus Docker plus N8N running. It's really only consuming a third of a gig, which is really nice. Processing wise doesn't do much. A lot of clean stuff running. Over here you can watch this output just to make sure nothing weird is running, so you can kind of optimize there. You can also watch the I/O to see if things are just writing to disk like crazy. So with this setup, what we can see on this panel over here is you want to keep an eye on the temperature of the device. This runs at a pretty consistent 46 when it's idle, 46 Celsius, so you want to keep that under 60 most of the time. As low as possible is always good. This is just running a fan at 3.35 or 3.3 or whatever volt, as opposed to 5, because it works well enough and it's not loud that way. I never hear this thing sitting on my desk. It's totally quiet. It's great. The temp.fs. Now keep in mind what I just mentioned is that on one hand you can get away with dumping all your logs and all your writes to this temporary file, but if the server goes down, all those logs go away. So if you need those logs, you need to come up with a backup strategy. For example, you could push them out to like Google Cloud Log. You could have them offloaded somewhere. Or if you just don't care, like in my case, because this is mostly a development in progress thing, you could just dump those logs. So that it really depends on what you're doing. If you need to audit it, offload it. If you don't, you can just put them in RAM for now. So I've let this thing run so far for 7 days in the background, and it really doesn't accumulate that fast. I was hard pressed to get over maybe 100 megabytes of logs. So far so good there. So all that logging and the ability to send the folder of logging to this this temporary file storage, which is basically RAM, you can set that up in FTab. That's another thing we could get into as well, but let's just say that's configured for now and keep moving with the story here. So the bottom right hand corner shows the output of the Docker log for the N8N container, because in the background, let's see, Docker PS, there's an N8N container that's running, which contains N8N and exposes it on port 5678. Well, the thing about it is, we'll get into that in just a second. N8N needs a way to communicate over the network through HTTPS, because if you can't set up HTTPS, you can do some things where you can pass like an override to it to disable some secure cookie stuff, but really then you've got traffic on your network that's unencrypted, which is just kind of bad practice. So we're going to use Nginx to set up an HTTPS connection and then serve it across. So you could probably do that in Docker. You could set up an Nginx Docker container, but in my case I have Nginx just running locally on the device, and then I've got N8N running in a container. So let's look at Nginx for a second. I'm going to make this larger. Let's clear that out. So if we go to Nginx, and let's look at the sites available, and we'll take a look at this configuration for N8N. It's kind of a doozy, but we'll get into some of these pieces. So the first thing is that, at least in this setup, when you're listening on port 5678, that's the port that you're going to ultimately end up serving the content on. So in the case of our Docker configuration, I'm just going to look at that again real quick, Docker PS. You can see that this is forwarding 5679 to 5678. And it's doing that because it's allowing Nginx to handle that traffic at that point. And Nginx needs to handle it because it needs to set up that secure connection. So let's go back into the file we were just looking at. So you listen on that port for SSL. And this the server name up here is set to your IP address. And then the certificates is the next piece. So you have to generate your own certificates. Now, since you're using your local network and you're using a local network address, those certificates need to be made relative to the local network. And this is another piece that could just be its own tutorial. But essentially you need to create a certificate authority, and then you need to sign the certificates using that authority. And so that's the part I'm still smoothing out, but works up to this point, where the syntax is a little picky when you pass it to a browser to make sure, if trying to get rid of the little red slash, but it'll still work and it'll still secure it with that slash in it. And so that's what this setup currently has. And then down here, some of this protocol and cipher stuff, some of it might be an over explanation, but it's articulating the type of connection we want to make with HTTPS, the cipher that it's going to use. It's giving as much information as possible. And then if we scroll down a little bit, the other thing that is pretty important to all this, you get this proxy set up, get the headers in place. Make sure WebSockets are configured, because without this WebSocket and extra configuration, N8N is going to get confused. And it's going to run like really slow. So you want this extra configuration in here. And I'm pretty sure it's the WebSocket thing that makes it flow nicely. Okay, so high level, Nginx needs to be configured to handle HTTPS and talk to the Docker container. With those things set up, you also got the Docker container. There's a ton of instructions on how to launch an N8N Docker container, but essentially it's install Docker, go to N8N, install the N8N container, and then I guess I could probably write a compose file for this. I just haven't had time yet. You would just want to make sure that the port routing is correct here when you launch this command, and that you're going to forward in the way that it's forwarding. So you let Nginx take care of that traffic. Otherwise, it won't work. So this is going to let Nginx take care of it. And when that's in place, then you've got this nice connection going where N8N is being served on your local network using HTTPS with your local IP address. So let's go back to our configuration screen for a minute. So go in here, and we've got our handy monitor script. Oh, I'm already in. Sometimes I forget I'm in TMUX. So there we go. Now back here, we can see that NAN is running in this tiny window, and it shows this local address down here. Now in your browser, when this launches, you want to go to the HTTPS version, but first you have to upload your certificate to this. So it's something like going into here, going into settings, and then every browser is different, but in there somewhere there's certificates. And when you find certificates, yeah, it's under security, manage certificates, authorities. You got to upload your own authority to this thing to allow it to get that far. So this would be import, and it's going to look for I believe it's .crt file, and that file is generated in the process of you creating all this stuff. And it's a few steps. I mean, you're looking at stuff like let me show you an example real quick. You're looking at some stuff where, yeah, here we go. So for example, the key flow process. You generate the CA, which is the certificate authority. This could really be its own tutorial, so I'm just really going to gloss over this. If you want more info, let me know, so I don't spend a bunch of time doing it. So generate the CA private key, and that's going to be used to then create the CA. And then you create a CNF file, which is a configuration template, which looks kind of like this. And so this is going to be something you can fill out and then pass to the command line to configure this thing, because they're really picky about the configuration. Like, you got to get it just right, and I don't even have it 100% perfect yet. But you fill out one of these configuration files, essentially. And then after that, you pass the configuration file and the key you just created to create the certificate authority.pem file. After that, generate the OpenSSL configuration, and so that's the second config file. And now at this point, you're creating certificates from your authority. Generate a new key for creating certificates. So you've got two keys at this point. One is just reserved for your certificate authority. The other one is just reserved for signing new certificates. And once you go down this process, you're heading down the lane of creating more of these files. So then you've got your CSR file that gets generated, and then after that you get your certificate using your CA, and that creates a PEM file and the CSR file. Lots of good stuff down here. And then once these different keys are created, you then pass them to the Nginx configuration, which we saw earlier at the top of the file. It needs these keys. So when you create all that stuff, you create the key sequence in order to create the HTTPS communication. You end up with that file that you then ultimately pass to the browser. And once the browser has it, then it goes, oh, okay, yeah, like I recognize that this is like from a source that I don't totally trust, but I'm going to allow you to click through to access it. Once you can do that, then you can get enter files. You might be able to configure this in such a way where you don't get this non-secure, and that's what I'm working on now, but that's currently where I'm at. So once you have all that in place, Nginx will serve N8N, and you can probably do this with traffic too. It's another program you can launch with the N8N Docker stuff. There's a lot of ways to do this, but essentially this is the end result, where you can get into N8N here. And so with that loaded up in the bottom right hand corner of this monitor, sorry if this is looking confusing here, this area here, this log, if I run N8N, we can see that this log is going to pick up all the Docker container commands. And so this lets you kind of like watch your setup as you're trying to figure stuff out. Yeah, so that's like a high-level whirlwind of how this thing goes together. You're basically like setting up the Pi, and once the Pi is set up, you then configure the operating system, maybe turn off the GUI for it. Then you SSH into the thing. You set up Nginx, in this case, to handle HTTPS traffic. You set up Docker. Docker launches N8N, and then configure N8N to work with Nginx by setting up that port stuff. And you're also setting up all those keys to configure the Nginx HTTPS communication. Once that's done, you then take your cert file and you hand it to the browser. Then the browser will allow you to go to your local IP address on the right port and connect to N8N. I mean, it's a lot of steps up front, and I'm looking to either use Ansible or something to automate a few of these steps. But right now I'm in the stage where I'm like smoothing it out. Like, this is it possible? And the answer is yes, definitely possible. So yeah, that's the takeaway, is that if this is something you're thinking about getting into, this is just one approach. And it's definitely possible to configure and run some cool stuff. And I'm sure there's even better ways to do this. So if you got any advice for me, go ahead and leave it in the comments. I might look into traffic. I'm also looking into proxy stuff, because right now you can't do like a web hook, for example. It might be possible to do with a VPN attached in the mix. So yeah, there you go. Hopefully this was helpful, interesting, inspiring, and not a total waste of your time. And yeah, I don't know. It's probably time to stop talking. All right, enjoy that internet. Thanks.